Assalamualaikum warahmatullahi wabarakatuh, and hi to my students. This is the second version or the remake of the video lecture for the title 3.3 Curve of Polar Coordinates. For this remake, I try to make my explanation better. After you already know the fundamentals of polar coordinates, which represents by this r and theta, where r is the distance between the point and the origin, while the theta represents the angle. So based on this given representation of polar coordinates, we can sketch several shapes given a different function of r. So for example, let's start with this following. Sketch the following curves might be more accurate for this instance. So imagine there's a function r equals to 3 and the theta is arbitrary. So if we sketch the axis, okay, the polar axis, you imagine a point where it always remains the distance 3 from the origin, and also the angle is not mentioned here, so it can be any angles. So imagine if I start at the x-axis here and the distance is 3. We rotate at the angle from 0 and we try to move anti-clockwise up until pi, until 2 pi. So let's start to rotate first. We arrive at pi over 2. We proceed again, maintain the distance of 3. This will be pi, 3 pi over 2, and also we stop until the full complete 2 pi. So as you can observe here, it will be a shape of a circle with a radius of 3. Let's move forward for the second one, B. The difference just now is right now is negative 3, and in this instance, if r 3, so if r is negative, then it will be on the opposite side, with plus with pi. Okay, so r negative 3, it still will be a circle with a radius of 3. Nothing special here actually. And if we try to look at the next one, r equals to alpha sine theta, I will skip this one first because this will define as another kind of circle. If I put E first, theta is defined as pi over 4. For this case right now, r is not defined, whereas the angle is fixed at pi over 4. Pi over 4 or 45 degrees. So you imagine, you try to put a point here. Okay, we draw a 45 degrees first, or pi over 4 first. This is pi over 4. This is the angle. And this dot, all of this represents the same angle with a different magnitude of r. Imagine this one is 1. If I try to, this one is 2. The distance is not accurate if I represent like this. If I put, suppose there's a curve there. The curve here is 1. Curve here is 2. And the curve here is 3. Different r but the same angle, pi over 4. And it extends up until here as well. If we connect the dots here, it will be a straight line. In other words, if the r is given by not r, r is arbitrary. If we given a fixed function of theta equals to pi over 4 or 45 degrees, it represents a straight line. So let's look at the next example, which is r equals to alpha, a sine theta. The explanation is already in the slide as well. As you can see here, I just do the explanation. Okay, this is for the case of a circle as well, but it's not the center is not at the origin. It has been shifted there. A sin theta, if you want to try to get the idea, why not we try to represent theta as a collection starting from 0, maybe pi over 2, pi, 3 pi over 2, and also 2 pi back to the origin. Right now, what is sin theta? 0, 1, 0, -1, and also 0 back. Okay, right now A is not assigned as a value. Let's put as an example right now, our R is 1 sin theta. So 1 sin theta will be 0, 1, 0, -1, and 0. And let's try to sketch this into the idea. Based on this table, when the degree is 0, the distance will be 0. I'm going to show you, if you put into a more smaller section of pi over 4, you can see the projection will be moved here, and during pi equals to pi over 2, it has the distance of 1 here. Next, during the pi, you move forward, the distance becomes 0 back. Okay, bear in mind, for 3 pi over 2, it will be -1, so it will be at the opposite side of -1. R -1, it will be at the opposite side. Recall back from the previous 3.2, and during the 2 pi, it will be 0 back. As you can see here, R equals to 1 sin theta, the value of A there is 1. The center will be 1 over 2 here. So that's why when you represent R equals to A sin theta, the center will be A over 2. And what is A? Basically, A can be defined as, because this is a shape of the circle, you can see it as a diameter as well. And the more accurate representation is that A is better to be said as the distance between the point, the distance from origin, like I say. So if I give you another example, R equals to 4 sin theta, the basic idea you can get is that the diameter will be 4 on the top, because this is a sine and a circle, and then the center will be 2. Let me adjust it a little bit. Okay, there you go. The basic form of A sin theta. In the case of A cos theta, if it will be positive, let me finish, okay? If A is positive, then the circle will be at the top, and if R equals to -4 sin theta, then basically we can have the idea is that it will be a circle with the center of -2, and the diameter is the coordinate will be at the -4 for the point of the end of the diameter. Positive at the top and the negative at the bottom. For the case of cos, it almost the same principle. The difference this time is that if the A is positive, A cos theta, then it will be on the right, and the center will be on the x-axis as compared from the previous sign. And for the case of negative A, then it will be on the left. But the basic principle remains the same. It will be a circle with the origin of a over 2. Okay, let's move forward. This one has already been discussed, and okay, this is a special case of r equals to theta. Okay, this one is very hard to draw. This you can just happens to know if r is made be equivalent as the angle theta, then it will be a spiral. Okay. All right. Now we move forward. If from the r equals to this one is cos, so let me start with the sine first. The previous one we discussed about whether plus minus a sine theta, plus minus a sine theta. This one will be it ends with a circle along the y-axis, where the center and the a, the point coordinate of a, will be on the y-axis. This is a cardioid, and the cardioid, the basic form will be there's a value of a plus minus b sine theta. You add up a here. Okay, cardioid is a class of a limacon. The basic, the larger classes of this a plus minus b sine theta is a limacon, and cardioid is a subset of the limacon. The name cardioid implies that if you want to identify the cardioid, if the value of a is equivalent with b, if a is equivalent with b, will be a cardioid. Okay, I checked with your the remaining slides. You will not discuss if the a is larger than b and a is lower than b. So let's take for this case is a equals to b. Let's start first with this representation. R equals to 1. 1 is positive right now, is plus sine theta. And the table has already been done here in the form of a trigo curve. Curve ni kita bawa ke atas sikit. Imagine right now if we don't have any basic idea to have this value, I advise you to start with 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, you can have more points, but this is fundamentally enough for you to sketch. And you start with the sine theta, 0, 1, degree 0, negative 1, and also 0. Then we move forward by adding up 1 at the front. 1 plus sine theta becomes 1, 2, 1, 0, and also 1. Okay, this step by step can make sure you visualize and sketch this better. Okay, now let's sketch it in the polar plane. It starts when the degree is 0, then it will be at 1. So imagine there's a point here which starts at 1 at the x-axis, and when it goes rotates to pi over 2 anti-clockwise, the distance grows to 2. So one curve, this is 2. When it moves forward to proceed to pi, then it goes back to 1. This is negative 1. The distance r is 1 right now. Although it shows here 1, remember this is a polar coordinate. R represents the distance between the point with the origin. So the point with the origin right now, although it's, if we put it in the Cartesian coordinate xy, it will be negative 1. But the distance is still 1. It does not violate that. But the interesting move comes next, where the distance becomes 0. From this one, it reduced to 0. it goes smaller and smaller towards the origin, so the curve move forward from the -1 to 0, and moving forward to anticlockwise to 2 pi, it goes back to 1. It will be an inverted heart shape there. Although I don't draw it very smoothly, but you can get the picture that cardioid is a heart shaped curve. Several points that can be derived from this example is that if I put r equals to 1, okay, this is 1 plus 1 sine theta. Okay, again I mentioned that if A equals to B, then it will be a cardioid. I want to tell you, if this is 1 plus 1, you can see here, this will be A, this will be 2A, this will be A, and of course this is 0. You can use this as a reference to sketch the next cardioid. So my point is, for example, if I put R equals to 2 plus 2 sine theta, okay, then I can have a rough idea that this will be 2. If we move forward to 4, goes back to -2, to the origin and back to 2. So this will be a rough sketch of 2 plus 2 sine theta. Again, if you involve sine, then it will be along the y-axis. If we move forward to the cos, dia tak ada cos ke sini, ada ke? Ada, okay. Let me show you the example of cos. If I give as A plus minus cos theta, let's put a value right now, r equals to 1 plus 1 cos theta. Okay, you can do a basic sketch by using the table to verify this, but let me tell you the basic general shape, and then you verify by the table later. This will be 1, this will be 2. So 1 plus cos theta, or 1 plus 1 cos theta, it will be in the shape of like this. Okay, this will be again xy. If A plus cos theta, it will be a heart shape on this shape, and if I change to r equals to 1 minus cos theta, here will be minus 2, again the same 1 and 1. So this is the basic shape if it involves cos. So my challenge to you guys is that try to verify this by constructing the table, and I already did in my online lecture with my section. So we already discussed if the center and the origin r equals to a certain value, r equals to 1, for example, it will be mentioned by, it will be visualized by the circle with the origin 0, 0. If it represents only the angle, it will be a straight line, and if it involves a sine theta or a cos theta, it will be a circle and the respective axis. And also we have a cardioid, which represent as a plus minus sine theta or a plus minus cos theta, and a equals to b for the case of cardioid. And that's all about the function of the curve of polar coordinate. Let me proceed directly by showing the symmetric test. Okay. Symmetric about the ray. Okay, we have three classes, and for this subject, let's focus only on the simple x and y, and this is ray theta equals to 0. Theta equals to 0, mana dia? Dia dekat starting point of x. So if I have a curve like this, okay, I just randomly sketch a curve there, and if it is a symmetric at ray theta equals to 0, it means there is an inverse image where ray theta represents as a symmetric line. So the symmetric will be here, the mirror image will be here. This one, it represents as ray theta equals to 0. Vice versa, if you put ray theta equals to pi over 2, okay, here pi over 2 90 degrees, so it will be at the y-axis. Then you imagine that this curve will be a mirror image to the pi over 2. So two major things that needs to be focused on is that doing ray theta equals to 0 on the x-axis and ray theta equals to pi over 2 on the y-axis. To show that it is symmetric, then there is a special proof that needs to be shown. So we will focus on ray theta equals to 0 first. As you can refer at the slide on the left here, imagine if it is symmetric at ray theta equals to 0. Okay, an angle theta here and the mirror of the green color there, so the mirror line will be here. These two angles is similar. If this is theta, then the bottom one will be negative theta because we move on the clockwise. To show it is symmetric at ray theta equals to 0, then you need to prove that the function of theta will be equal to f negative theta. Later we will go on the example. If it is symmetric at ray theta equals to pi over 2, imagine there's an angle here, and if it's the symmetric line along the ray theta over 2, pi over 2, it will be here. And this angle is the same size with the pi over right. But if we want to read this, it will be the original reading in terms of polar coordinate will be from here to this dotted line. Okay, therefore we must pi minus pi is 180, pi minus minus this theta, and then to show that it's symmetric at the rate theta pi over 2, therefore you need to show that f theta is equal with f pi minus theta. That is where we get the idea the idea to prove that it is similar. Okay, now let's proceed to the examples. Okay, so for this question, okay, consider we have a polar curve of r equals to 2 cos theta. Okay, and then it starts with, okay, show that it's symmetric. Okay, ingat ray theta equals to 0, therefore you need to show f theta equals to f negative theta. And then try to find what is f theta first, which is definitely 2 cos theta. And f negative theta will be 2 cos negative theta. As for now, it is not similar yet. By using some of the trigonometric identity, cos negative theta is cos theta itself. Therefore, f theta equals to f negative theta. This is a simple proof to show that this f theta is indeed similar with f negative theta. But the case is not similar. You cannot use this the same properties for the sine. Now it asks for plot the curve of 0 until pi over 2. Okay, so we try to plot it. And then 2 cos theta, okay, the basic shape, it will be here, the distance between the diameter 2 and up until pi over 2 only. So up until pi over 2, it will be a semicircle head there. And by using the symmetric property, it says that the ray is at here, at axis. Therefore, you use these symmetric properties, you just complete this circle. So there you have it. You will have the circle. Okay, the complete drawing is shown there. If you want to construct a table, actually the question does not require you to construct a table. But again, if it asks you if you construct a table, you can get the picture much more clearer. Alright, I want to add up more question for this one, because it states that it is show that it's curve, it's symmetric, and I already proven to you that at ray theta equals to 0, it is symmetric. But for this one, I add the question, determine whether it is symmetric at ray theta equals to pi over 2. Okay. Right now it's not shown. We want to identify whether it's symmetric or not at ray theta equals to pi over 2. And to show that whether or not it's symmetric at ray theta over 2, I need to show f theta is indeed equal to pi minus theta. And then f theta for this question, direct to cos theta. For f pi minus theta, it will be 2 cos pi minus theta. And I use a supplementary identity where it states as cos pi minus theta is actually equals to negative cos theta. Alright, so proceed here, it will be 2 negative cos theta. I simplify, it becomes negative 2 cos theta. As you can observe here, f theta equals to 2 cos theta. F pi minus theta equals to negative 2 cos theta. Therefore, f theta is not equal to f pi minus theta, and I put a conclusion is not symmetric at ray theta pi over 2. From the previous illustration also, it is a circle here. Okay, let me use other color please. Okay, for this representation, this is 2, okay. From this diagram alone, you can see that if you draw a symmetrical line at pi over 2, there is no curve here. So yes, 2 cos theta is not symmetric at ray theta pi over 2. This is very clear. Let's do one more example for this one, because this involves pi over 2. Okay, I will only do the first one, where it shows that, okay, given that r is 2 plus 2 sine theta, and you have the basic idea that this is a cardioid. Okay, show that it's symmetric at ray theta pi over 2. So what is f theta? I need to show first f theta is indeed equals to pi minus theta. Buat f theta dulu, 2 plus 2 sin theta, and then what is f pi minus theta is 2 plus 2 sin pi minus theta. Again, I use a supplementary identity. Later I will write down the identity. Okay, as sine pi minus theta is actually equals to sine theta, therefore f pi minus theta is 2 plus 2 sine theta. F theta is equals to f pi minus theta, and I already shown that is symmetric at ray theta pi over 2. Okay, let's take a look of the identity that I used. Okay, and I list down here for your future reference. Of course, you can use any other valid trigonometry identity, but I found this is to be more convenient. Sine, okay. Let me classify this into two types. The first, if we need to show pi over ray theta pi over 2. Okay, this one is for ray theta equals to 0. Okay, try to search for supplementary angles, identity. And for ray theta equals to 0, it involves opposite angles on the x-axis. So this is the identity, sine theta equals to negative sine theta. And it involves cos theta equals to, let me check again. Okay, so go back. Sin theta equals to this negative sin theta, and only cos theta equals to cos negative theta. Okay, for ray theta over 2, the thing that I can find to be useful, which involve pi minus theta, which is sine pi minus theta equals to sine theta. Okay. And then cos pi minus theta equals to negative cos theta. Because ray theta, kita kena tunjuk f theta equals to f negative theta. For ray theta pi over 2, kita kena tunjuk f theta equals to f pi minus theta. So I found this to be quite useful if it involves sine and cos. For tangent, kalau ada tangent, I just write it. Maybe we will counting this further. This is negative tan theta. Okay. So if you have any other identity that can use, then use it. But this is I found it to be quite useful for the question of symmetry. Continue to do your exercise, and see you in another video for the area of the polar coordinate. But before you proceed to look at the area of polar coordinate, I suggest you to be familiar with the basic representation of the curve. For example, r equals to a value theta saja, A plus A sin theta or A cos theta, and also the cardioid A plus minus sin atau cos. At least you have the idea to sketch. Okay, that's all for this video. Thank you and see you again on the next video. Goodbye.